In this video, we will discuss another important concept which again you should have learned in your course AI algorithms is regularizing your neural network. So as you can see in this figure, the first figure shows an underfitted model. The third figure shows an overfitted model, and the second figure is the one which is the most appropriate model. So as we know, regularization is a method to prevent overfitting. The first type of regularization which you should have been now already familiarized with is the L1 and L2 regularization, and if you are using L1 or L2 regularization, this is how your cost function would be changed. The second method of performing regularization, which is explicitly for a neural network, is a dropout. So dropout is one of the most frequently used regularization technique in the field of neural network. Here, at each iteration, it randomly selects some nodes and remove them along with all of the incoming and outgoing connections. As you can see, in this particular neural network, the nodes which are represented as cross are the ones which has been randomly removed from your neural network. And so all the connection coming to that particular node and all the connection that is leaving from that node will be automatically removed. So at each iteration, we now have a different set of nodes, and this results in a different set of output. Now, the probability of choosing how many nodes should be dropped is a hyperparameter of a dropout function. The next type of method for preventing overfitting is called as early stopping. Now, early stopping is a method which is used in the machine learning architectures as well as in the neural network architecture. So this is a kind of cross-validation strategy where we keep one part of our training set as a validation set. And when we see that the performance of the validation set is getting worse, we immediately stop the training of the model. So in this case, the training of the model is stopped from this particular position because after this particular position, actually the testing error is going upwards. The next method to reduce overfitting is what is called as to increase the size of the training data set. And one method to achieve this is by data augmentation. So data augmentation is a technique in order to increase the size of the training data set so that the overfitting can be prevented. Now, when it comes to machine learning, we were not able to increase the size of the training data set because we need a labeled data set. And we know labeled data set are very costly. But when it comes to data sets such as images, we can easily rotate the image or shift the image or scale the image or flip the image or increase the brightness or decrease the brightness and resolutions, and we can come up with another set of training images. So data augmentation is a method which has been commonly used in computer vision in order to increase the number of training images. So these are some of the techniques which are used in regularizing your neural network. And as we start to code our computer vision and our natural language processing problems, we will be using all these techniques or most of these techniques in different set of problems. Weight initialization techniques in neural network. So at this point, you might be aware that one of the starting point to take care of while building your neural network is to initialize your weight metrics correctly. This initialization step can be critical to the model's ultimate performance, and it is important that we choose the right initialization method. And there are different types of initialization techniques which you can use, again depending upon your problem statement, which is zero initialization, random initialization, he initialization, and Xavier initializations. So these are some of the important concepts which I expect that everybody know at this point of time. So in the next video, we will discuss the TensorFlow framework, and after that, we will directly jump to the computer vision problem domain.